What I have here is 3 motors running. They're a third horsepower apiece, and I'm going to show you that these type of motors, first of all, are inefficient, but the larger a motor, the more efficient it is. What I have here is a basic utility meter where I'm showing amps. Now normally utility meters don't show amps, but I want to show both, amps and then watts. Watts are what we're billed for on an electric bill. Now, I'm going to go ahead and turn on the auto-tune controller, and what it's going to show us is that these third horsepower motors here are very inefficient. In fact, if you look closely, you're running at 0.3 or 30% efficiency. That means that 70% of the energy that's being drawn into these motors are strictly to magnetize them. We're able to capture that energy and make it available to those motors automatically. I want to draw your attention to the meter again, because what I'm going to do, I'm going to turn on the automated controller. We're running about 14 amps and about 480 watts. Show you again. Now I'm going to turn on the auto-tune controller, and you'll notice our amps went down to about 3.9 and our watts to about 430 watts. A savings of somewhere in the area of 8 to 10%. We accomplish that through line loss savings. Now, the other thing is these motors aren't having to work as hard to get that energy to themselves. The other aspect of the auto-tune controller, a couple things I want you to see. What the motors are seeing is the same amps as they were getting before. They're just not having to draw it from the utility. Because this is an automated system, items change. I'm going to go ahead and turn off one of the motors and allow you for a moment to see that, hey, this is how things work in an average business or home. Things change. The automated controller is going to realize I need to adjust automatically because something changed in the environment, and we have this set on about a 15-second delay. We could set that anywhere from 1 second to 60 seconds, depending on, it's all a setup. But as soon as this gets to that 15 seconds, it's going to know it needs to adjust. It's going to do its best to keep this between 95% or 90, in this case, 98% efficiency. We want that efficiency always between 95 and 100%. Now again, I'm going to turn that motor back on. It goes back down. And it'll adjust automatically. In 15 seconds, it'll take that right back to 100% unity, and there you are.